The next chapter is based on errors in hypothesis testing. Now, why do we talk about errors in hypothesis testing? We all agree on the fact that a sample can never be a perfect replacement for the entire population. Now, let's take this example right here. What you did was you took 10 rods. The mean was always known to be 2 centimeters. You felt by the new positioning of the factory, you felt that the mean length has changed. Yes. It is altered, right? So you took upon yourself to take a sample of 10 rods. You measured the length of the sample of 10 rods and you found the mean length to come out to be 2.015. Now, according to the significance level set by the company, 2.015 is very much far off, is considered to be very much far off from the mean. So far off that you are now ready to say that this is wrong and we were right, that the mean length has changed. Now tell me something, the company is making maybe hundreds of rods. You took a sample of 10. I know you took perfect care of taking a random sample and maybe this was the biggest sample that you could get or whatever. You took the sample, you took all the care that is required for unbiased sampling, you took that. But your result still refuted the claim. Now, isn't there a possibility, I'm just discussing, isn't there a possibility that someday, or maybe because there are hundreds and hundreds of, let's say, rods available, you pick another set of 10 rods and the mean length of those 10 rods somehow is less than 2.012. Let's say it comes out to be 2.011. Slightly less than 2.012, which is the critical value. Isn't this possible? That by chance, okay, let's say by chance you come across 10 rods, you didn't handpick those rods, you took a random sample, but by chance you got such a sample of 10 rods whose mean length was less than 2.012. What would you do then? You would accept the null hypothesis, right? Now, which means this, that no matter how big a sample you take and no matter how random your sample is, there is always a chance of you actually rejecting a true null hypothesis. See, what I'm trying to say is this. You took a sample of 10 and on the basis of just 10 rods, you are trying to refute the claim of the company. Right? What if by chance these are those 10 rods that you got were the ones which were relatively longer? Maybe every other rod which is there in the inventory is very close to the mean. And you just somehow were just unlucky. You just ended up sampling those 10 rods which were just longer than the usual. Now on the basis of those 10 rods, you have actually refuted the claim, refuted the hypothesis of the company, and you're going to maybe reject the entire batch that has been produced. And you need to change the setting of the machine again. Now, the point is this, you do stand a chance of making an error because your calculation is based, at the end of the day, your calculation is based on a sample. No matter how much care you take, there's always a chance of an error. So this might have been possible that you have rejected actually a true null hypothesis. Just because you just by chance ended up with those 10 rods that just didn't suit your setting. Are you getting the point here? So you may have made what we call a type 1 error. A type 1 error is when you reject a hypothesis and in actual that hypothesis is actually true. That's when you say you made a type 1 error. Now tell me something, you have kept the rejection region of how much is the percentage of your rejection region? 5%, right? So can I say there is a 5% chance for any of your sample means to fall in this area? Can I say that? Yes. And when your sample mean falls in this area, do you stand a chance of making a type 1 error? So if I say, what are your chances overall that you would ever end up making a type 1 error? It's 5%. Because whenever you fall in rejection region, you may have made a type 1 error. And what are your chances of falling in the rejection region? For this given significance level, 5%. So therefore, you are always at a 5% chance of making a type 1 error. Are we good? So the next chapter, okay, this is a type 1 error. Then there is another error called a type 2 error. There are only two kinds of errors, type 1 and type 2. I'm sure you figure out what type 2 error is. Type 2 error is when you actually, when your sample actually falls in the acceptance region, you accept the null hypothesis and in actual the hypothesis was wrong. And you ended up accepting the null hypothesis. Again, now let's say the same example that I was giving you. What if these were not the numbers, these were not the 10 rods that you got, maybe you got another batch of 10 rods and those 10 rods mean was close to 2. Let's say that those 10 rods mean was falling somewhere here or somewhere here. You would have not rejected the null hypothesis, you would have accepted the null hypothesis. But then again, maybe by chance you just ended up getting the sample of 10 rods which had a mean length close to 2. Maybe every other rod that's there in the inventory is unusually longer. So you just by chance ended up with that sample. So you again stand a chance of making an error. An error which what kind of an error? An error where you've accepted the null hypothesis but in actual the hypothesis is wrong. This is called a type 2 error. So whenever you accept a null hypothesis, you always stand a chance of making a type 2 error. You may have accepted a wrong hypothesis. Because then again, your calculation is only based on the sample, that's the best you can do. So statisticians, as they know that their calculation is going to be based on a sample, so they also know that they stand a chance of making an error. So they are conscious of both. They are conscious of whatever analysis they are making, and they are also conscious of the chance of error that might happen, that might take place. Are we good? Okay, this is what the second chapter is about, and it's errors and hypothesis testing, and I just spoke about this. So a type 1 error is you reject a true null hypothesis. When does that happen? When you fall in the rejection region. And what are your chances of falling in the rejection region? Your chances of falling in the rejection region is equal to the significance level, because that's the probability of the area covered in the normal distribution of the rejection region area, right? So with a level of significance of alpha percent, whatever that percentage is, your type 1 error is basically alpha upon 100. So if your significance level is a 5%, that means your probability of type 1 error is 0.05.
So mathematically speaking, how do we know the null hypothesis is correct or not correct?
You can only have a percentage error that you can get. For that, you will have to check every single rod in the inventory.
No.
There is only a percentage of error that you can keep margin on, and then according to that, you make your decisions.
So over here in this chapter, we only calculate the percentage.
You can make the percentage. Here we only identify that are we making a type 1 error or are we making a type 2 error, and therefore what are the chances of making, what's the probability of making that? That's what we are concerned with at the moment. And then what generally statisticians do is they do the experiment multiple times.
So for sure.
So they won't like pick एक दफा एक 10 का sample निकालिए रॉड का चेक करिए तो कंपनी को रिफ्यूज कर देंगे. They might just do this multiple times. Like multiple times they might pick a sample of 10 rods and they would repeat the hypothesis and then maybe take out the result at the end. Because they know that there might be an error. And it also depends on what kind of a sampling procedure you've adopted. Is your sample large enough? Maybe if the statistician thinks the sample is very large compared to the population, so compared to any of the sample that you would take for that population, then maybe one experiment might be good for you.
So if you keep repeating the experiment, does the probability of you making a mistake go down?
No, it's not the problem of making a mistake. It's when you get to know then how many experiments. If let's say you did it 10 times, once your sample fell into the rejection region, but 9 times it didn't, what would you do? you would go with the ones that's 9 out of 10. So if 9 out of 10, it's not falling in the rejection region, you would end up accepting the null hypothesis. That's the point here. But at least you didn't base it on one experiment. Yeah. Okay, so a type 2 error, on the other hand, is accepting a false null hypothesis. Right? And that would happen if you would fall in the acceptance region. Okay. So, okay, now it's not so simple. Type 1 error is simply the probability of the rejection region, which is your significance level. But it's not the same for the type 2 error. Type 2 error is not exactly the probability of the acceptance region, because agar significance level is 5% and the acceptance region is 95%, then you would say, okay, so type 1 error probability is 0.05 and type 2 error probability is 0.95. No, it doesn't work that way. Type 1 error probability is 0.05, that's directly related to the rejection region. But for type 2 error, we need to know something more. We need to know what is the actual mean. See, you are saying, I accepted a false null hypothesis. Okay, you ended up accepting a false null hypothesis, so null hypothesis ठीक नहीं है, तो फिर सही वाली value क्या है? Until you don't know what is the actual value, you cannot ascertain the probability of type 2 error. So the probability of type 2 error calculation is based on the probability of the acceptance region, no doubt, but based on not the wrong hypothesis, based on the actual value of the mean. So that's what I've written over here. Type 2 error is probability of acceptance region with the actual mean, not with the mean that you were starting off with, the claim of the company. Because here you're saying that that hypothesis is false. That's why the whole discussion of the type 2 error is happening here. Because you've accidentally accepted it, but you know it's false. You somehow got to know it's false. So now because it's false, you obviously can't use that in a calculation, so you need to know the new one, the actual one. Once you get to know the actual one, then you can compute, okay, so this was the acceptance region that I was taking. This is what I had considered. Now according to the new mean, what are my chances of making a type 2 error? If this is the new mean. So I'll come to that. We'll do some questions, you'll understand that. And the power of the test by basically just 1 minus probability of type 2 error. So basically if the probability of the type 2 error is less, your test is more reliable. The power of the test increases. So even statisticians want to do this probability so that they get to know how much can they rely on the hypothesis estimation. I'll come to that. We'll do some questions, you'll understand. Okay, let's try this out. Okay, see, now let's have a discussion on type 1, type 2 according to this situation. A machine fills a 1 liter water bottles. When the machine is working correctly, the contents of the normally distributed mean this. This is what the engineer knows actually is being filled. This is what he feels. This is the claim of the company. This is how the machine, he knows that the bottles are being filled with an average of 1.002. Okay. So your null hypothesis is clearly, your null hypothesis is mean equals 1.002. But the performance of the machine tested regular intervals, mean content is calculated. If this mean falls below a certain value, it is assumed that the machine is not performing correctly. So our research hypothesis should be the mean is less than 1.002. It's a one-tailed test. Set up the null and the alternative hypotheses. Part A is done. For a test is 5% significance level, find the rejection region taking the sample mean in the test history. So we just need to identify the rejection region here. So it's a one-tailed test. Sample size is how much? Sample size is 9. We've already said a sample of 9 bottles is taken. Right? We don't need to know the sample, we don't need to know the mean of the sample because we're not testing, we're just identifying the rejection region at the moment. So mean 1.002 right in the middle. Rejection region on either sides. No, on the left side only. Yeah, it's a one-tailed test, it's only on the left side. So can you tell me the Z critical here? I think that will be based on the, yeah, your alpha is 5%, that means according to 0.95. Negative? Yeah, but what value? For a 0.95? No, not 1.96. 1.96 for a 95% confidence interval. If anyone has a table, can they check what's the Z value for 0.95?
1.645.
1.645. 0.95? For the probability of 0.95 is 1.645. Because this probability is 0.95. Okay, so minus 1.645. Alright? Okay. Can you convert, now see they are asking for the rejection region, so you need to convert the Z critical to the X critical. So let's convert the Z critical to the X critical. Do we have a standard deviation of the population? Yes. Standard deviation of the population is 0.02. So Z is equal to X critical minus mu upon sigma upon square root of n. So that's minus 1.645. X critical minus 1.002. 0.02 over
0.00. 0.00.
the standard deviation. Oh, 0.002, sorry. 0.002 divided by square root of 9. So, X critical value is
1.00.
1.00? 1.001? Okay. Are we all getting 1.001?
Yes.
Alright, so the rejection region is X bar less than 1.001. That's your rejection region. So if we ever do the test and the sample mean comes out to be less than 1.001, that's when you reject the null hypothesis. If it's over 1.001, then you don't reject, you accept. Okay. Determine type 1 error. Can you give me the probability of type 1 error here? It's going to be 0.05, that's it.
0.5.
It's the significance level. Type 1 error, 5 divided by 100. Type 1 error is directly the significance level, the probability of the rejection region. What is the probability of the rejection region? 5%. Area is 5%, it means the probability is 0.05. That's the probability of type 1. For type 1, you don't need any calculation. For continuous hypothesis, you don't need any calculation. The type 1 is directly the significance level. Right? Is everyone okay till here? Any questions? Everyone's okay with type 1? Okay. Type 2 error. Now, guys, whenever they will ask you for the type 2 error, they will also provide you with the actual value. Without that, you cannot calculate the type 2 error. Now see, here is saying, find the probability of type 2 error if the mean content of the bottles has fallen to a nominal value of 1 liter. That means this is the actual. The actual is 1 liter. It's not 1.002. It has actually fallen. So see, the idea is this. Let's say you take a sample and your sample mean falls here. What would you do?
Accept.
You would accept what? The null hypothesis. And what is the null hypothesis? 1.002. But, and how would you say I might have made a type 2 error? It's when you would say, oh, I've accepted the null hypothesis, but maybe I'm wrong. Maybe I've accepted an actually wrong null hypothesis. Right? And if the hypothesis is wrong, what was your suspicion from the start? That mu was supposed to be? And see, now he's saying that he found out that the actual mean is not 1.002, it's 1 liter.
1 minus 1.
Matlab 1.00, I mean 1 liter is less than 1.00. So that's the actual mean. Now he's asking you what are the chances that he might have made a type 2 error, or anybody who would do the test would make a type 2 error. So on the basis of the fact that the actual mean is 1, not 1.002, you have to find out the probability of the acceptance region. See, यहाँ पे नहीं, यहाँ पे तो probability is 95%. It's 0.95. This is not type 2 error. This probability is not type 2 error. Because this probability is based on the wrong hypothesis, which is 1.002. You just got to know that the actual hypothesis is 1 liter. So what are the chances someone might do the test, would end up making a type 2 error? So you would find the probability of this blue area, but based on not mu 1.002, but based on mu 1. That's what you need to do. So can I just clear this? Is everyone okay? Can I just clear this? Okay, so basically what I'm trying to say is, see now your rejection region, see now your acceptance region is going to change, by the way. The shape of the acceptance region will also change. Your actual mean that you just found out is 1. Your rejection region is from 1.001 till back, which means your rejection region starts somewhere from here. Where would 1.001 be? On the right or on the left? And your rejection region is x bar less than, that means all this is part of the rejection region. This is the actual acceptance region.
So this only uses significance level.
नहीं, उस significance level की base पे आपने rejection region बना लिया है. Now that means rejection region बनाने का मतलब है कि okay, let me put this down. If the rejection region is x bar less than 1.001, what is the acceptance region?
Greater than 1.
Yes, acceptance region is x bar greater than. This is the acceptance region. Do we agree on this? Now, but nobody is denying this is not the acceptance region. We are just trying to find out the probability of this region, but based on the actual mean, not 1.002. If you base it on 1.002, the probability of this is 0.95. So we already know 95% error का chance थोड़ी है आपका type 2 का. How can there be a 95% chance of an error of type 2? It doesn't even make sense, right? So your chances of making an error would be based on the fact that actually mean है क्या? So actually mean is 1, and therefore this acceptance region is here. So the probability of this small area will give you the probability of you making a type 2 error.
1 minus.
So we need to get the probability. Now the z value is also going to change over here. Obviously the point has shifted. So can you compute the new z value? You know, you have the mu value with you. You know that the x value over here is how much? Your x value over here is 1.001. Can you find out the z value? Because once we have the z value only, then can I find out the probability of this blue area. So z equals x minus mu upon sigma upon square root of n. X is 1.001, mu is 1, sigma is 0.002 upon 3. Give me the z value. 1.5 what? Exact 1.5. Okay. The z value is exact 1.5. Can you check the table and see what area does 1.5 provide us? Z 1.5. Z 1.5 gives us an area of 0.9332. This area is 0.9332. So the area that we require
0.06.
is 0.0668. This is the probability of making a type 2 error. You stand a chance of making a type 2 error by 6.68%. There is a 6.68% chance that you would end up making a type 2 error. If had you accepted the null hypothesis based on those calculations. Because you didn't know, you were basing on 1.002 and you would end up accepting the null hypothesis if the sample mean would have fallen in the acceptance region. But the actual mean is 1 and therefore you stand a chance by 6.68% of making a type 2 error.
So, this will root 3.
Root 3?
Root 3. Root 9.
Root 9 Root 9 and 9 is the sample size. So root 9 का 3 है ना? क्या है इसमें? Okay, can you just follow the procedure? If you want to make us calculate the type 1 error, type 2 error, type 1 error if you want to calculate, that's exactly equal to the significance level. Okay? If you want to calculate type 2 error, first thing you need to do is you need to identify the acceptance region. Which means you have to first identify the rejection region. आपने calculate कर लिया, this is your step 1. Step 2, you get your rejection region. The other region left is the rejection region. Step 3 is this. This is step 3. You remap your acceptance region based on the new mean, based on the actual value that is. The whole idea of type 2 error is that you have accepted a wrong null hypothesis. That means the actual value of the hypothesis is something else. You based your calculation on 1.002. Actually it's not 1.002 and you ended up accepting it as well. So the examiner will give you the actual value, because unless you don't have the actual value, you cannot reposition your acceptance level and you cannot calculate the probability of value. So the probability of the type 2 error is the probability of the acceptance region, same region, this region, but based on the actual mean value. So when I put the actual mean value here as mu1, my acceptance region was 1.001 and ahead. So 1.001 started from here and ahead, right side. This is the acceptance region. So the probability of the acceptance region, but based on the new value of mean, that probability is your type 2 error. So you stand a chance of making a type 2 error by 6.68%.